A factory is monitoring sensor data to optimize operations. The current setup ingests telemetry through Amazon Kinesis data streams and archives it into Amazon S3 using Kinesis Data Firehose. Now, management needs a dashboard to visualize live operational metrics on a large facility monitor, specifically focusing on achieving the lowest possible latency.
Let us look at the options. Option A suggests using Amazon Managed Service for Apache Flink to process the stream, writing results to Amazon TimeStream, and using a Grafana dashboard. Option B involves configuring S3 to trigger an AWS Lambda function on object creation, writing to Aurora, and using Amazon QuickSight. Option C uses Flink, an additional Kinesis Data Firehose stream, TimeStream, and QuickSight. Finally, Option D uses AWS Glue for real-time processing from S3, writing to TimeStream and Grafana.
In my view, the correct answer is Option A. To achieve the lowest latency, real-time streaming data must be processed directly from the source, which is Kinesis data streams, rather than waiting for it to be persisted in S3. Using Kinesis Data Firehose to reach S3 introduces buffering delays that are simply incompatible with live, high-performance monitoring requirements.
Amazon Managed Service for Apache Flink is specifically designed for sub-second real-time stream processing, making it the most efficient choice here. Combining this with Amazon TimeStream, which is purpose-built for high-velocity time series data, and visualizing the output with Grafana provides an optimal real-time monitoring solution.
Options B and D are unsuitable because S3 object notifications and AWS Glue are fundamentally batch or micro-batch oriented, which adds significant latency. Option C is also inefficient because routing data through an additional Firehose delivery stream adds an extra hop and unnecessary delay. A quick tip for your exam. When designing for low-latency streaming, always prioritize direct processing and avoid intermediate batching layers.